All right, so on page 4 we have a few problems. They're the find the mistake type problems, critiquing others and so on. But I think, at least in this stage of the game, the preferred way to go about it is just solve them ourselves and see how our solution and theirs either match up or don't match up. All right, so for the first one, we have 3x squared minus 11x equals 4. We're looking for a solution using the zero product property. The zero product property tells us that we need to have, well, in the case of quadratics, two factors that'll multiply to give a result of 0. All right, so got a bunch of things wrong here. One, it's not equal to 0. All right, and 2, I don't have two factors. All right, so I need two factors whose product is equal to 0. All right, so I'm going to subtract off the 4 first so that we have everything over to the same side, leaving the 0 alone on the right-hand side. All right, so one of the requirements of a zero product property is now fulfilled. We have it equal to 0. The second requirement is that it's in factor form. So I need to factor this trinomial. All right. So I'm looking at a trinomial whose factors will be a product of binomials. We can assume the 3x and the x. 3x times x is 3x squared. It's just a matter of getting us to that negative 4. All right. So if you think about the different ways in which you could multiply to equal a negative 4, that'll get you going in the right direction. It could be a 1 and 4. We'll have to play around with the signs in a minute, but just the absolute values, 1 and 4, 2 and 2. All right. So if you're lucky, you'll hit with the first attempt, but I'm going to pretend that I don't know the answer already because I theoretically haven't done it 2 other times today. So let's say I assume it's 2, 2. All right, I use my arc diagram to verify. 2 times x is 2x. 3 times 2 is 6, so 6x. There's no combination of positives and negatives that's going to get us from 2x and 6x to a negative 11x. All right, so those can't be the right factors or the right constants. So I'm going to get rid of the 2 and the 2. So that's not a winner. So I'll try the 1 and the 4. And if it doesn't work in this order, I'll flip it around and try it in the reverse order. All right? But I'm looking at 1x, 12x. That'll work if the 1 is positive and the 12 is negative. All right, so I have my factors. Now I'm going to take my factors and set them equal to 0 because the zero product property tells us that two factors whose product is equal to 0, if you have two factors whose product is equal to 0, either of those two factors can themselves be equal to 0, either or both. So 3x plus 1 is equal to 0. Not both at the same time, but both would satisfy the zero product property. So 3x plus 1 is equal to 0. X minus 4 is equal to 0. All right. I'm going to solve for x in both cases. In the first situation, I'm going to subtract a 1 from both sides. And then divide by the 3. So I'm looking at x is equal to negative 1/3. The other one's much simpler. Add 4 to both sides. And we're looking at x is equal to 4. All right, so that's one solution. Now, we could have gotten this solution using the calculator, All right, let me just show you that real quick or review that with you. So I'm just going to get all this AP stat stuff off of here. So I put 3x squared minus 11x minus 4. And I put 0 as my second equation. So 3x squared minus 11x minus 4 goes in for y1. 0 goes in for y2. I'm just looking to see where those two intersect. All right, so I'll do a zoom 6. I see I have two intersections, one here and one here. Pretty safe bet that this is intersecting at 4. So I'm pretty confident about that one. All right. But the other one, maybe not so much. So I do second trace 5. And I get as close as I can to that intersection. And it's not really going to get too close. But then once you get as close as you can get, hit enter, enter, enter. It says negative 0.3 repeated. Most people can recognize that as negative 1/3. If you're not one of those people, that doesn't mean that you're lost and you're not going to get stuff right. You just have to do an additional step. All right, so that additional step would be going into the home screen. So second mode to quit. You see above mode it says quit. If I hit the X key, it'll bring up that decimal value, that negative 0.3 repeated. So then from there I would just hit math, convert it over to fraction form, math frac, and it'll convert it to the negative 1/3 for me. All right. So we'll get there. It's just a question of how many steps it'll take to get there. Now, something else that you may have noticed, may not have noticed, when you solve for your roots or x-intercepts or solutions, it relates, or they relate, to the factors. All right, we talked about it a little bit yesterday, but we didn't really get into what happens when you have a fractional solution. All right. If you look carefully, you see that the ingredients that make up the factor 3x plus 1, those same ingredients are in the solution x equals negative 1/3. Right? So the denominator, that 3, corresponds with the coefficient, and the numerator, the 1, corresponds with the constant term. All right? The sign is always the reverse between the solution or the root and the factor, but most of the time you can just kind of piece it together anyway, using the arc diagram. Now, you may look at the 4 and say, well, that's great for the fractions, but that doesn't work for the 4. Well, it actually does, because 4 could be thought of as 4 over 1. That 1 is the coefficient of x. There's an understood 1 in front of the x. That 4 is the constant term there. So you could actually use your roots if you're struggling to find the factors. You could use the calculator, come up with the answers, and even in the fractional situations, that'll kind of guide you towards the appropriate factors. Right? So, just something to keep in mind. The next one, x squared is equal to 6x. Zero product property tells us that we need to have two factors whose product is equal to 0. Right? Product is equal to 0. Equal to 0. Meaning the right-hand side has to be 0. So let's get rid of that 6x. So I have x squared minus 6x. I'm looking for two factors, which means I have to factor this expression. All right. I have two terms, so I wouldn't use my trinomial methods here. It's not a difference of two perfect squares, although there is a difference and there are two things. They're not all perfect squares, but I do see a common x. So GCF would be the way to go. So I could divide each term by x. We hang on to the x. Because if I told you to give me two numbers that multiply to 35, and you're like, okay, well, I know one of them's 5 because, it's in the 35. I see a 5 right there. So you take that 5 and divide it into the 35, you do 35 divided by 5 and you come up with the 7, you don't just toss away the 5. Right? You still need the 5 because it's the 5 times the 7 that gives you the 35. Right? Here, we saw that there was a common x. So we knew x would go into the x squared minus 6x. So we divide that expression by x. The result is wonderful. That's x minus 6. But I also need the x. All right? I don't just throw away the x because it's x times the x minus 6 that gives me the product that I'm looking for. All right? So, and that's the key to understanding where the mistake happened in their solution, because they lost the x. They divided by x and then they tossed it aside. All right? So that seems to be where the issue is. All right? So x is equal to 0 or x minus 6 is equal to 0. Add 6 to both sides and you get two solutions, x equals 0 or x equals 6. All right. So it's pretty easy to see what happened there. I mean, aside from the fact that they just only got half of the answer, it's x equals 6 or x equals 0. They just came up with the 6, but it happened, well, basically, they didn't follow the zero product property. It happened in this step. The choice to divide everything by x was incorrect. All right, they needed to subtract the 6x from both sides. All right, going back to the previous one, they just screwed up the factoring. Everything else seemed to be okay. They forgot their or symbol also, but that wasn't the big issue. The big issue was that they factored incorrectly. All right. The last one, the big issue there is that they did everything incorrectly. All of this is wrong. Just awful stuff. All right, and that's because x squared plus 4, poor quality squiggly bracket there. This is a sum of two perfect squares. All right, it's not factorable. All right, except for the trivial case, where you can factor out a 1. That doesn't really help. So it's not factorable. Now, if we think about the zero product property, two factors whose product is equal to 0. Well, if it's not factorable, I can never come up with two factors. All right? So the zero product property does not apply. All right. So yeah, they did everything wrong. So what did we learn from that? Well, hopefully, the more times we talk about it, the more it's likely to stick. And that is, anytime you see a sum of two perfect squares, it's not going to be factorable. So don't try to factor it. All right? The only thing you could ever do in a situation like that is maybe pull out a GCF, but even that's pretty rare. All right. So